Welcome to Sravz technical series. In today's session, we will discuss Airflow and Airflow task mapping. So in the tech sessions in the Airflow task, previously we discussed Airflow plus task to generate stock statistics, and then we integrated that in the UI. So per user request, today I created this video where we will remove task and use Airflow task mapping to uh, get the ticker fundamentals and upload those to the AWS S3. Before that, we'll do a quick demo. So in the Sravz UI, if you go to the fundamentals page, the fundamental page shows the stock fundamentals. For example, I picked API Corporation. So the API Corporation details, we have a lot of data displayed there for the API Corporation like this. And then the raw data is a JSON file, which is displayed like this. So in today's session, it's a huge JSON file. In today's session, we'll use Airflow to grab the fundamental data for all these 5690 tickers in the system and upload those to AWS S3 for today's session. In a later session, we will use those 5K tickers to do analysis on the fundamental data. So I'll quickly go over the previous session we went through with respect to task. In the ticker stats generator video, we used Airflow, then we used task to do a massively parallel ticker stats generation. So Dask is a framework where using SSH, the Dask scheduler schedules tasks on the Dask workers, and through the SSH, it pickles the tasks, sends them to the workers. The workers will run the function and return the data to Dask scheduler. And then Airflow DAG was doing the scheduling via Dask. In today's session, we'll remove Dask and we'll use Airflow task mapping to run the same tasks parallelly on Celery cluster. So I'll switch over to the Airflow fundamentals uploader page. So before that, I'll just go through the architecture diagram of Airflow. At a high level, Airflow has a web server, a scheduler has an executor, which is Celery in this case, and Celery workers run the jobs, and then all that jobs are status is pushed to a metadata database like Postgres in our case, and then the web server is the user interface where we can see the DAG status, etc. And there's a DAG directory where we save all our DAG files, which are Python files, which are picked up by the scheduler and then schedules them on the Celery worker. So I picked this image from the Airflow documentation. Now, before we go through the task mapping flow, I'll just go over the statistics page we integrated last time using Dask. So if you go to the year-to-date analysis page, so in the year-to-date analysis page for close to 5,600 stock tickers we have, we generate the statistics. So these are the statistics generated using the Dask Airflow worker in the previous session. So we converted that Dask-based workflow to Airflow task mapping. So I'll go to the DAG for the Airflow task mapping. So in the DAG section, if we look at the Airflow tasks, so summary code stats, in the previous session we showed it using Dask-based scheduling. Now it is based on tasks. And we are running Airflow 2.6.3. This task mapping was introduced in 2.6, so we need the latest Airflow installation. So this is the latest, the last DAG run. And if you look at the DAG run, we have the details, the graph. The graph will show a task @ task. It's a decorator. After this task runs, we finally do upload ticker stats task, which dependent on the previous task. When all these tasks are run in parallel, the final task will upload the tickers to the AWS S3. Since this is a mapped task, if I click on that, it will show the mapped task. So it takes an array of tickers. In our case, there are 11 batches of tickers. So that's why it shows 11. And so there are 11 mapped tasks. So from 0 to 10, there are 11 mapped tasks. And each task runs parallelly on the celery cluster. In our case, it's right now the is not running, so it doesn't show any active task. So each task runs in parallel on the celery cluster, and after all the tasks are complete, the final task runs, and then this task uploads the tickers to the AWS S3. I'll go over the code base for this one. So this is the task mapping flow I was discussing. So we have a scheduler. Scheduler picks up the tasks, checks the task status from PostgreSQL, and also checks the task status from Redis salary broker. And then the salary workers take the work from salary broker, which is Redis in our case. And once they run each task, they update the Postgres database. And using Airflow web server, which we saw here, we can see the task status. So it's a broker-based system. And these are the screenshots of the task group and tasks in a group. I'll go through the DAG source code. So this is the general DAG, the DAG framework we use to write a simple DAGs. So this is all basic DAG framework. To use a task, we have to use at the task and at the task group decorator. So before we discuss the task and task group, let's discuss a basic task. So we have two tasks here, and in the DAG context, with DAG context, we start the first task. So we get all the tickers from the database, and then we batch those tickers into 10 batches. So you would have an array of array, and in the first array you would have up to total number of tickers by batch size, which is 10 in our case. So if there are around 5k tickers, we'll have in the first array 1k tickers. In the second array, in the first array we'll have 500 tickers. In the second array we'll have another 500 tickers, and so on into 10 batches. The last batch will have the rest of the tickers. Since we have around 5500 tickers, we will have around 11 batches. So we send each batch of tickers to the get single ticker stat task, which is get single ticker stats task. So it takes a list of tickers. So there'll be around 500 tickers in this task, and then it will call the actual function to get the stats from each ticker in that 500 tickers, the first batch and the second batch, and so on. So once all the 11 tasks are complete, upload ticker stats is called. Since we are waiting for upload ticker stats, waits on the result of the previous task call. So we pass status to this task. So this task is dependent on the previous task, and so we create a dependency between these two tasks. Once all the 10 tasks are complete here, then this task would run. So that's what the UI shows here. So we batched 5000 tickets into 11 batches. So each batch had around 500 tickers. So once all the 500 tickers are complete, all the tickers are processed, we call the upload ticker stats. So we'll switch back to the code base. So to do a dependency chain between tasks, Airflow provides a function called expand. So get single ticker stat is a task. So once we apply a decorator to this task, we will get a function called expand. The expand function takes a key value pair. In our case, it is tickers, and the tickers is an array of array. So the expand would map this array of array to each task. So since there are 11 instances of the task, each task would get one array among those array of arrays. So that's how each task will process a batch of tickers in that 5,000 tickers. And once all the tickers are processed, we call this task and pass the result of the previous task to upload ticker stats. And that's how it uploads the ticker stats to the AWS S3. So that's how tasks are mapped among them. Airflow provides another mechanism called task grouping, where you can group a bunch of tasks into a group, and once that group of tasks are complete, you can chain them to another task. So in the next DAG, this one, I used a task group instead of a task. In the previous discussion, we used two tasks. This time we would use a task group. A task group is called first. So a task group will take all the tickers, and then each array, the array of arrays, is sent to the task. So it's a visually different, it shows a different way in the UI. Other than that, the workflow is the same. So I'll quickly go to the other task group image screen. So we have stats. So if you look at the graph here for a task group, a task group will have bunch of tasks, and all the tasks run within the task group. So this way, the graphical representation is different. Instead of a chain, you would have a grouping of tasks. So then you can lay down your task groups this way in multiple task groups, then chain those task groups to another. So that way you can create a complex workflow. In our case, this task group would have 10 tasks. So it's a map task. So it had around 11 tasks within that task group. And all were successful. And we were able to upload the fundamental data of all 5,000 tickers to the AWS S3. So I won't execute it, but if you see the duration, it took around 55 minutes, and they were scheduled on the Celery cluster here, and the cluster has around 50 workers. So this is the Celery cluster where we were running the tasks. They are around 50 workers, and right now, since the DAG is not running, we don't see any active tasks specific to the DAGs we discussed just now. So with that, I'll close today's session. If you have any questions or comments, please reach me out in the discussion section here or in the YouTube channel. Thank you for watching.